The Nanotech Institute has started a research collaboration with the Temptime Corporation in the area of diacetylene time-temperature indicators, or TTIs. The idea of a TTI using the color changes brought about by diacetylene polymerization was first conceived by Dr. Ray Bachman, director of the Nanotech Institute. Temptime Corporation put this novel idea to work by developing a very special kind of label that uses a diacetylene ink that changes color irreversibly when heated over time. These labels are especially useful to indicate when perishable products such as food or medicine have expired from prolonged exposure to heat. These indicators are currently saving lives around the world in developing countries where distributing temperature-sensitive medicines and vaccines is a serious problem. Over 1.5 billion TTIs have been used on vaccine vials to assure cold chain integrity in their delivery. These indicators are being used by the World Health Organization in their global fight against the crippling disease polio. The young child in the photograph is receiving drops of the orally administered polio vaccine. A similar line of TTIs has also been developed to assure food freshness in fish, meat, fruit juice, and are even used by the U.S. Army in their MRE rations, or meals ready to eat. How do diacetylene time-temperature indicators work? The diacetylene monomer molecules self-assemble to form well-defined crystals, which are generally colorless. The monomer crystal structure guides polymerization and structural assembly to yield perfectly aligned polydiacetylene chains, which are intensely colored. The width of the polydiacetylene chains is on the nanoscale, and close to the diameter of carbon nanotubes. Like for carbon nanotubes, two-dimensional electron confinement provides the utilized optical properties. Diacetylene monomer microcrystals are coated as inks onto product labels. The activation energy for thermal polymerization is tuned to closely match the activation energy and degradation rate for the product application. The color change in the ink is then simply compared to a reference color printed onto the label. These indicators are inexpensive, irreversible, reliable, and simple to use.
Polio vaccine packed in ice, safe for several days, is being distributed to thousands of vaccinators in northern India. This is the largest public health campaign in the world today, a last-ditch effort to eradicate polio from the face of the planet. Unlike smallpox vaccine, polio vaccine deteriorates quickly when it's taken from the ice packs. So heat-sensitive labels on the vials turn different warning colors as the fluid passes through 4 stages of deterioration. 2 precious drops of vaccine are given orally, and an indelible mark put on the small finger acts as a record. One more child will never get polio.